Hello, today we'll be doing an introduction to vectors. Now, if you're a physics student, you'll know the difference between a vector and a scalar. A scalar is simply just a quantity with a magnitude and no particular direction. Some examples of this are distance or speed. If we were to have, say, a distance of 5 meters, this would be just a number with, well, just a magnitude. There's no particular direction. With vectors, on the other hand, there's both a magnitude and a direction. Some examples of vector quantities are displacement, velocity, or force. Now, if we were to have, say, a displacement of 2 meters to the north, well, this number has both a magnitude of 2 meters and a direction, north. And this will be different from a displacement of 2 meters to the east, because even though they both have the same magnitude, they have different directions, so they're not equal. Now, how can we look at a vector from a geometrical standpoint? Well, a vector can be denoted by an arrow that starts at one point and ends on another point. Say we have point A and point B. An arrow that goes from A to B can be considered a vector, and this vector can be represented by AB, A, or however you like, as long as you have an arrow on top to indicate that it's a vector. Now, how would we look at the addition of vectors? Well, let's say we had a vector AB, which means it starts on a point A and ends on a point B. And let's say we had another vector, BC, which means it starts on point B and ends on point C. Now, if we were to plot this on a graph, and let's say the origin is point A, and if we replicate this arrow or this vector AB, it would be something like this, where the origin is point A and now this is point B. Now, if we added this arrow BC onto the end of the arrow AB, we'd get something like that, where because this starts on B and ends on C, so this would be point C. And this means that when we add these vectors, we're going from A, which is the origin, to C. And that means it would be the same as directly going from A to C in a straight line, which means vector AB plus vector BC is equal to vector AC, because this arrow that goes from A and ends on C can be vector AC. And let's look at this from another perspective. Let's say we were to have 3 points, point A, point B, and point C. And together, these points would form a triangle. And A to B would be vector AB, B to C, vector BC, and let's say A to C is vector AC. Now, let's say we want to do vector AB plus BC. Well, what does these vectors actually mean? Well, vector AB means we're going from point A and we're going to point B, or we're starting from point A and going to point B. And vector BC means we're going from point B to point C. So as you can see, we started on point A and ended up on point C. Now, you may notice that, well, this is the same thing as directly going from point A directly to point C. So, which would be vector AC. So based off this, we can say that vector AB plus vector BC is equal to vector AC. And this is pretty much the same thing as this example over here. Now, what if we wanted to look at the subtraction of vectors? Well, similarly, let's say we were to have 3 points that together form a triangle. And this would be AB, BC, and this would be AC once again. Let's say we want to look at BC minus AC. So again, for our first, we can rewrite this and say this is equal to vector BC plus negative AC. And what does negative AC actually represent? Well, when we multiply a vector by -1, we're simply reversing the direction, but keeping the magnitude the same. So the opposite direction of going from A to C would be going from C to A. So negative AC is simply equal to C positive CA. So again, this can be rewritten to BC plus CA because CA is the opposite direction as AC. And from what we previously learned from this example and this example, BC plus CA is simply going from B to A, which is equal to vector BA. So vector BC minus vector AC is equal to vector BA. Now, how can we apply this and look at a example question for this? Well, let's say we had a ball and this ball is exerted, or a force is exerted on this ball of, let's say, 5 newtons south, and another force exerted of, let's say, 7 newtons to the east. How can we find the resulting force on this ball? Well, as we know, this if we were to add these vectors, it would be simply either putting this arrow to the end of this arrow or the other way around. So if we were to do this, it would look something like this. And now this would be 5 newtons over here. And this would be our resulting vector. And since this is a right angle, we can easily use trigonometry to find this angle, which would be square root 49 plus 25. And that would be the magnitude of the force. But how do we find the direction? Because a vector has both a direction and magnitude. Well, once again, using trig, this angle here is the inverse tan of this over this. So 5 divided by 7. So this will be the direction and this would be the magnitude.